Hey guys, I hope your spring break went well. Winding down now. This lesson is for Monday, April 20th, 2020. As you can see on the screen behind me, we are now in Module 19, and we will be working on Lesson 19.1, which is Understanding Quadratic Functions. Guys, the way you're going to have to work this today is watch this video, maybe go back and look through it a few times. First lesson is a lot of vocabulary, things, terminology, things that you need to know in order to complete the questions. So as a way of getting started, we're going to first look at the parent function. So if there was a 1 in place of where the a was, okay, 1x squared, which just, we write that as x squared, that graph will be called the parent function. Here's the graph of the parent function that you see in front of you. I may be getting a little bit ahead of myself, but I want to give you some starting point. So you can see that the vertex or the bottom of this graph, this is called a parabola, will start at 0, 0, and then face upwards. But that's the graph of f of x equals x squared. So guys, when you look right here, this is a function f of x. It equals ax squared plus bx plus c, and we're going to put some numbers in there in a minute that are going to affect the picture that we draw. But anyway, this is referred to as a quadratic function. Okay, and we're going to look at the graph of that quadratic function in a sec. So as I mentioned a minute ago on the whiteboard, the first thing, the most basic form of the quadratic function is right here. F of x equals x squared, and that's called the parent quadratic function, the parent function. Now, when I graphed the parent function, first off, the way we ended up with this graph was we picked values that were near 0. We picked 0, we picked 1, we picked 2, we picked 3, and then on the other side, we picked -1, -2, and -3. So when we put those in place of the x, 0 squared is 0. Okay, 1 squared is 1, 2 squared is 4, 3 squared is 9, and then on this side of the y-axis, -1 is 1, -1 squared is 1, -2 squared is 4, and -3 squared is 9. So the resulting graph of this quadratic function is called a parabola. The point that is at the lowest spot of the parabola, where the parabola starts to turn, where it turns, that point is called the vertex. And in this case, the vertex is at the origin at the point 0, 0. Now, as you can see, there's a line here that separates. Now, let me move this up a little bit. Okay, there's a line that separates this parabola into two equal or symmetrical parts, and that line in this case is the y-axis, and that's called the axis of symmetry. And like I said, in this case, it's represented by the y-axis. So now in the event that a is greater than 1, so we go back to our quadratic function that says g of x equals ax squared. So let's say the a is greater than 1. What that's actually going to do to the graph is make it more narrow and make it more of a stretch. So the blue represents our parent function, which the a was 1. In the event that the a is greater than 1, now we're going to have a stretch, and it's going to be a more thin or narrow graph. So anytime the a is greater than 1, the graph is going to be more narrow. Now, let's suppose instead we have the a is somewhere between 0 and 1. Not equal to 0, not equal to 1, but a fraction, like, 1/2 or something like that. Now the red graph, as you can see, becomes more wide. Okay, you can see how the width now becomes more significant as opposed to the blue graph, which was our parent function, where a was equal just to 1. So in the event that a is equal to 1/2, 1/3, 1/4, it's going to cause the graph to become a little bit wider or more compressed. Now suppose that the a is a negative number. When a is negative, now the graph turns downward. Okay, so you can see the parent graph for -1 is in the outlined in blue, okay? And then if it's anything higher or lower than that, actually, like -2, -3, whatever, it's going to become a more narrow graph again. And you see that the red faces down. So when your A is negative, okay, you're going to have a downward graph. Okay, a little more terminology. Now that we have the graph facing downward, because the A was negative, a downward facing parabola, the vertex, which here is 0, 0, that would be called the maximum point. So the vertex in a downward facing graph going down is called the maximum point. And again, with an upward facing parabola where the A was positive, now the vertex would be called the minimum point. Okay, so I'm looking over the questions that you were assigned, and some of them talk about whether the graph opens up or down. Okay, so remember that if it's a positive A, it's going to open up. A negative A means it's going to open down. The vertex being maximum or minimum refers to whether the graph opens upward or downward. And that maximum or minimum refers to the vertex for that parabola. And then whether it's a stretch or a compression, the graph is going to be stretched or more narrow in the event that the A is greater than 1. And if the A is less than 1, okay, but greater than 0, then the graph is going to be a little wider or compressed. So as a way of reviewing, first off, the function f of x equals ax squared. Let's suppose we were given 2 to put in place of the a. So now we have f of x equals 2x squared. What does that mean? Well, it means the graph will have a vertex of 0, 0. How come? Well, if I picked 0 for x, 0 squared is 0. 0 times 2 is 0. Therefore, our y, or f of x, would be 0. So 0, 0 would be our vertex. That means we would have a minimum point of 0. Minimum point. Okay, because the graph is going to open upward. Since the A is positive, the graph will open upward. And then last but not least, since the A is greater than 0, okay, greater than 0, let's start again. Greater than 0 plus greater than 1, those two things mean that the graph will, 1, open upward, and 2, it's going to stretch or be more narrow than our parent graph. Okay, now we're going to switch the A and make the A 1/3. So the A now is greater than 0 but less than 1. All right, and what does that mean? Well, again, if we put 0 in place of the x, we would get a y value for our ordered pair of 0, 0. So the vertex is going to be 0, 0. Since 1/3 is positive, that means we're going to have an upward graph. The graph will open upward. And then last but not least, because we have a fraction in the A spot, 1/3, okay, we're going to have a more wide graph than the parent function. So we're going to end up with more width. And tomorrow when we start putting values in place of the x and then for f of x, you'll see that why that's the case. But right now we're just working on terminology and understanding what these numbers in the A slot do to our graph. Now if we put a negative value in for A, -2 in this case, what will that do to our graph? Well, the big change is just that it's going to open downward. Similar to if we had 2 or 3 or 4 in the A slot, it's going to stretch and be more narrow. Anyway, but it is going to open downward now. So the point 0, 0, that's our vertex, will now become what's called a maximum point. It's a maximum point. All right, so that ends the lesson, first half of lesson 19.1. So now you have some idea about the terminology and terms that go with understanding quadratic functions. Guys, you're going to go to Google Classroom, open up the form that I have there, the Google form. There's 6 questions. The answers are either A or B. You only get one chance, so please view the video maybe a couple of times to refresh your memory before you do those questions. You can't go back and change any of your answers, and there will be a grade assessed based on how you make out on those 6 short A or B answers. And now we'll get started with the rest of 19.1 on Tuesday. This is the first half of 19.1 for Monday, April 20th, and then we'll go forward from there. Have a great day. If you're still on vacation, enjoy yourself. Practice social distancing. See you soon.